to buy fewer US cars. If the price of US oranges goes up, we're going to buy fewer oranges and maybe buy them somewhere else. So basically, it's inversely related, and I'm going to say, like, not positively related. If prices go up, imports go down. All right, everybody? Good. Now, just to make stuff simple, T equals 0. Tax function equals 0. Everyone in this room can do this. I want to know aggregate expenditures. Spit it out. Let's have it. Give me a shout when you're done. I think I'll just relax here. You guys have, like, you know, short sleeves shirts and stuff, but where are the summer colors? In this whole room, there's white and there's black, and variations there on. Erica's the only difference. A couple of blues up there, one blue over there. That's pretty pitiful, people. It's a more lively world than that. There's colors up there. Okay, who's got an answer for me? Erica, you probably would. No, we're not going to let you do it. Somebody else is going to do it. Who's going to tell me the answer? Aren't you excited to move forward with this thing? Are you doing that? Poor Erica, she's all ready to go on. The rest of you guys are holding her back. What is it? Tell me part of it. Somebody tell me part of it. I'll figure out the numbers now.
I got aggregate expenditures equal to 15,000 plus 0.6y minus 6.
Okay, good. Okay, let's do this. 13,000. Is it 13,000?
15.
Now, what is aggregate expenditure, sorry?
15,000 plus 0.6y minus 6.
Okay, 15,000 plus 0.6y minus 6p. Okay, interesting.
Sorry, minus 4.
Okay, I like it a lot. What do you guys think, the rest of you people? Without meaning to make light of this, if people can be shot on the Dundas streetcar with nobody around with a small little knife, you people can be shot for screwing this up. You know what the answer is. I want to know if this is the answer. How can you teach people who are brain dead? Come on, tell me. Tell me. We only did this all the way through for the last couple of weeks. I've seen you. Okay, go ahead.
Maybe 13,200 plus 0.6y minus 80.
All right, 13,200 is another claim. I'll just put it like this for the moment. We'll decide which one it is. 13,200. I really appreciate you speaking, Alexandra, because
He's right.
he is right. You were just inconsistent, right?
Yeah.
But you've got to be careful, everybody. This is flat out simple. This is what I'm trying to point out to you. But you can make a simple mistake. Notice, it's the same old thing. C plus I plus G plus X minus IN. 13, 2,000, right? Minus IN. And Alexander did this perfectly. 0.7 plus 0.2 minus 0.3 minus, right? On the exam, I'm going to give you that for 2 marks. All you're going to do is not mess it up, right? You're gonna get the 2 marks. So notice, this is easy to get. All right, there's aggregate expenditure, right at that. All right, now, let's use that aggregate expenditure. Can you plot aggregate expenditure? Oh, let's do this, everybody. Where am I here? Can you see the one that has a circle on it? Okay, very good. Okay, good. So let's see now. Here's what we're going to do. Okay. Now, follow this. This whole course, you guys have been learning to think about how you use diagrams and this and that. So you're going to know exactly what I'm going to do here. On the bottom is real Y, which, by the way, is also the axis of the above here. On the bottom is the price level. I'll just get rid of price level and put P for simplicity's sake. You know it is a price level. Right? In hundreds, say. And up here is real aggregate expenditure. Okay. Now I want you to take that equation, I'm going to put up here in the corner here, just to, maybe I can get down here, can I? That's up right. Okay, over here in the corner somewhere here, AE equals, what do we have? 13,200 plus 0.6y minus 8p, like this. All right, let's stick that up there somewhere. Okay, ready? There it is. Okay. Can you plot that AE in this diagram here? Could you plot the AE function? Could you do that? Why not 8?
Only 2 axes.
There's only 2 axes and we've got 3 variables, right? Okay, here's what we're going to do. Let's get rid of one of the variables. Now watch. I'm going to do this with equations, but I'm going to simultaneously do it with the diagram. All right? Simultaneously with the diagram. All right. So, let us pick what I want to, okay, say P, let's say P equals 100. Okay? Then, if P was equal to 100, we could solve AE. I'll move it over here a little bit. Then, AE would equal 13,200 plus 0.6y minus 8 times 100. Right? Why was I not doing that? All right? Everybody, we agree? And therefore, okay, by the way, so let's do this. That's there. So now we've got, notice there's an AE and there's only a Y. Everybody? Okay, on the diagram, I'm going to do this. This is P0. It is equal to 100. You might remember this when I was deriving deriving demand functions from indifference curves and budget lines. It's not the same. We're picking a price. We see the price gives an AE, so I need an AE function here. Notice that this AE function, let's simplify it, is now, by the way, 7,200, everybody, plus 0.6y. By the way, can I plot that on this diagram here? Can I do that over here? Can I? Of course I can. No problem. Because the intercept term is 7,200.
Not 5,000.
What is it? 5,000, yes. Nice. Thank you for paying attention. 5,200, everybody? Okay? And we've got this, like this, And of course the slope, right everybody? This is AE equals 5,200 minus 0.6 y. All right. Can we find equilibrium y? Yeah, Tim, sorry, go ahead.
It's minus 800 at the end, so should it be what?
Oh, is it, oh yeah, I'm sorry. Thanks. It seemed a little bit over the top. Good. So I'm glad you guys are on top of it. 12,000. And we want 400. Okay, good. So this is 12,400. So we don't have to, the price effect has something to do. Prices affect some part of the expenditure, not all of it, but some part of it, all right? So now we've corrected it. How am I going to find equilibrium income on this diagram? Yeah, go ahead, Erica.
A equals y.
A equals y, so we've got to do that. Right? Like this, say. And that's the AE function. That gives us y, like this. Call it y0. And you know what that does? That is the y that's associated, because that's equilibrium y. Notice it? That's equilibrium y. That's the y we want. We want that y for that peak. So just bring this down like this. And this is 1 point on the aggregate demand function. Okay, now here I have to solve this. So this is going to imply y equals 12,400 plus 0.6 y, which is equal to 12,400 divided by 1 minus 0.6. For Zad, what is it? Is it for Zad or for Zan? For Zan. Forgive me. Farhaz? Farnaz, yeah, sorry, Farnaz. Farnaz, what's the multiplier? Just look at it. What's the multiplier?
31,000.
No, the multiplier, Huh?
1 over 4.4.
And what would that give you? Well, you got a calculator. What's 1 divided by 0.4? 2.5, right? That's the multiplier. So it turns out this equilibrium y is, what is it then, Farnaz? Sorry about screwing up your name. I'm kind of out of it right now, for some reason.
31,000.
31,000 exactly? Beautiful, like it. Yep, because of that 400. So this is the equilibrium right here. $31,000. All right. So then, that's accurate, that's that, 1 point. Okay, let's do it again. What do you say? What if price was, let's say P is 60. What do you say? Tell me what aggregate expenditure is. AE equals what? Okay, what's equilibrium y? 31,800. Is that correct? Okay, good. How do we do this diagrammatically, everybody? On the diagram, let's call it P1. P1 equals 60. This then means aggregate expenditure falls. Intercept term I'm exaggerating, but here it is. This is Wait a minute, net aggregate expenditure shifts up, honestly. This is 12,720. Bring this down. Bring this across. P0, P1. There's the second point on aggregate demand. And we have 31,800. Okay, everybody, what is the distance, by the way, conceptually? Maybe we don't have to do it conceptually. Yeah, okay. Like this. This distance here. What is that conceptually? Without numbers, what is that distance there? What is it? But you all know what it is. It is the change in A due to the price change, but aggregate expenditure changed, right? Aggregate expenditure changed by 320, right there, notice? Times what? A multiplier. Aggregate expenditure went up by 320 because prices fell. That caused a multiplier change in equilibrium income. Right? Notice that, very important. And so then we get a demand function. In this case, it's going to be linear because of the way I set it up. And this is aggregate demand, AD. All right, everybody? Notice how I've derived it from changing prices. This is the derivation of aggregate demand. Changing price, sketch out the relationship between the price level and equilibrium income. This is an important idea, but it won't be tested per se, except calculation class. What this really gets us to is the next step, which is this. Let's get down here somewhere. Okay, so let's just remember that junk over there. I'm going to peel this stuff off. Okay, so what I'm going to do is this. Let's get rid of all this stuff over here. Like this and this. I'll make this a little less steep just for my own purposes. Okay. So, now watch carefully. This is very important, everybody. We're getting to a step here that is fundamental. Okay, so let us say the economy, we're going to link things up. We're going to say this is equilibrium right here. I'm sticking this in for the moment. This is the long-run aggregate supply without really explaining it. But I'm sticking it in for the moment like this. And then we have this business here. I think we had 12,400, I think. When this is, notice, AE0 at P0. Everybody? So this is the aggregate expenditure function at P0. If you change prices, you would sketch out this aggregate demand function down here. But I'm gonna take this as given. All right, now you have to tell me what happens over here. What is the effect of an increase in G equal to plus 100, okay? On the diagram, what is it? Over here, G goes up by 100, what do you guys do? Actually, hang on a second. These should line up, forgive me for a second. This should be like this. I'll move the aggregate demand function just to line it up, so hang on. Okay, this is 31,000, which by the way, is potential GDP right here. Okay, this is our original equilibrium. I apologize for